Okay, so the first principle we are going to talk about is the principle of superposition. And this just states that as layers are deposited on top of each other, the younger ones are deposited on top, covering up the older ones on the bottom, right? So any sequence of undisturbed rock layers, we call these rock layers strata. The oldest layer is on the bottom, and successively younger layers are located at higher and higher levels. Think of it like pancakes, right? If you get a stack of pancakes, you know the top pancake, it's the hottest, it's the freshest. The bottom pancake was made first, it's the oldest. Okay. So you can go out to the Grand Canyon or any other canyon on Earth or anywhere, even a road cut where you can see layers of rocks, and you can figure out which rock is youngest, that's going to be on the top, which rock is oldest, that's going to be on the bottom. Now, the principle of superposition is super easy when the rocks are deposited flat, right, on top of each other. So there's a clear bottom and there's a clear top. However, if these strata, if the rock layers have been folded, tilted, overturned, it can be a little bit more difficult to figure out, well, what's the top and what's the bottom? Right? In these instances, a geologist has to examine these layers, these strata, for clues to figure out, well, which one's the oldest, which one's the youngest, which one's the bottom, which one's the top, right? If there's fossils in these strata, this is even better because we can tell just by the orientation of the fossil often what's the bottom, what's the top. Okay? So these are clues are helpful in determining which way is up. And we know that we're able to determine which way is up, even if the rocks are tilted or folded, because of the second principle, which we call the principle of original horizontality. This states that sediment is deposited in layers that are originally horizontal, right? Just like pancakes, they're originally deposited flat, flat on top of flat on top of flat, which means that if you see rock layers that are tilted or folded today, right? If you get your pancakes and your pancakes have been delivered to you upside down, spilled on the floor, right? You know that they were at first horizontal. It was after they were formed that they changed their orientation, but these rocks were originally formed horizontally, right? So the principle of original horizontality. Okay? We know that even if we find rocks that are tilted, when they were formed, they were flat before being tilted. All right, the next one, the principle of original lateral continuity. This states that rock layers extend continuously in all directions for vast distances until it thins out or encounters a barrier, grades into something different, right? But just generally think of it as rock layers spread out for long directions and all over the place, right? They're laterally continuous, just like your pancake, your really big flat pancake that spreads over your entire plate, laterally continuous. The significance of this is that if you go to, say, the Grand Canyon or any other erosional feature, and you see a rock on one side of the canyon, that looks a heck of a lot like a rock on the other side of the canyon. Even though they're not connected today, right? They're separated by that canyon. We can presume that they were connected in the past. They used to be one lateral sheet of rock, one strata, before the canyon eroded down into it. Right? So here's an example. You go to a canyon and you see some jagged red rocks on both sides of the river. Well, you can assume before the river eroded that it used to be one layer of red rock. Okay. Finally, the fourth principle is the principle of cross-cutting relationships. And this says that a geologic feature that has been cut is older than the feature that does the cutting. Right? So for example, you've got your stack of pancakes. If you take your knife and you slash down, you cut down into the pancakes, creating a break in the pancakes, that cut has to be younger than the pancakes, right? It had to happen after the pancakes were already formed, right? So whatever cuts is younger than what is being cut. Right? So this could relate to something like a fault, or that's a crack in the rocks, or a dike that's like maybe magma intruded into the rock, cut through the rock, something like that. The dike, the fault would be younger than the rocks that it cuts across.